Section 7.6 Bubble sort using pass-by method. Bubble sort algorithm we learned in the chapter 6. So we use the bubble sort method to sort array, a teacher number array in ascending order, if you remember this. Now in this section, so we will improve this program, improve the bubble sort program. We will use these two functions, bubble sort and swap. So bubble sort function sorts the array, and the swap function so is change the order of the elements. So it change the array elements, array J and array J. We know for function pass parameters to a function have the two methods, passed by value and passed by value. Passed by value. So we send a copy of the parameter to the function. Passed by reference, we send the memory address of the parameter to function. Okay. So this they are different. So bubble sort. So one code swap to swap the element of we use by reference. So this means we will use the memory address of each array element. Okay. So all the entire arrays are automatically passed by reference. So this is actually default in C. We know array's name is just the memory address of the first element of the array, right? Individual array elements are data as just numbers are ordinarily passed by. But the function bubble sort use the address operator under each array element in the swap function. So this is passed by right. So this is the function like this. The swap ampersand array J. So we know array J is the element of the array. Then ampersand symbol. So this one gets the address of this element. So this is just the memory address. The value is not the value of the array J. Comma, then similarly, the ampersand array J. So this function just gives two memory addresses of the two array elements. Then functions will receive the memory address import variable element 1 ptr just for Okay, so this is the original swap function we used in chapter 6, the bubble sort. So use a temporary variable. So int hold equals array j, then array j equals array j plus 1, then last array j plus 1 equals 4. So use these three statements. Then if we use in the code, so int whole equals star element 1 point ptr point. So star, so we get the value that the memory saved in the that memory as well. Right? So this is just then star element 1 point equals star element 2 point. So element star element 2 point equals so also star. Okay, so this is the function. So include sharp include stdio.h, so we always use this library. Standard input output library. Then sharp define size. So this is the array size. Array will have the 10 elements. Then void bubble sort int star constant array comma constant size t. So bubble sort function, this is the definition of bubble sort. All it has the two parameters. The first one for define. So this is constant point to array. Okay, so point is constant, but array, that means element value could be changed. Just the point. Then constant that t size is number. Then main body int main void. Now define and assign the int a size. Size is 10, 2, 6, 4, 8, 10, 12, 18, 9, 58, 45, 57. So let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1. You know, this is the full definition. This is unordered. Okay, so then put data items in original order. Now just show it on the screen. For size t I equals 0. Then semicolon I less than size, this one symbolic constant, plus I, curly brackets, print f %4d, comma a. So %4d, d for decimal, that's the integer. Then 4, so each number is 4. Then called bubble sort function. So bubble sort a size t. So a is the array length. Array length, we know is just the memory address of the first element in the array. Okay, so it's memory address. This is also defined a constant constant point. Then size t, so 10, this is also constant. So this is the bubble sort. So should now put the array in the ascending after calling this function. Now put backslash n, so we know this is new line, right? Then date items in ascending order. Next, the for loop again. The for loop for size t, I equals 0, I less than size plus I, the same, printf 40, printf %40 a. So this is the same as the first for loop. So just show the array elements of it. Then the last one puts, so this one, this puts, so it's the empty tree. So this is just for moving on. Okay, so this is the main function. Then now this is the definition of the bubble sort. So void, so we know bubble sort, no return value. Then int star constant array, again, this is the constant point. Constant size t size. Okay, so this is another prototype. So void swap. Swap int star element 1 point, comma int star element 2 point. So define 2 points. This point point to int. Right? So for the swap, just define inside bubble sort. This is because only bubble sort function called this swap function. Also, this means only bubble sort function can call this swap function. Other any you can load called swap in the main function. Okay, so then for assign int, so pass equals 0, pass less than size minus 1, the plus. So this is also look through the whole array from the first element. It's because for array we know the index start from 0 in C language until the last second element. So this is the first for loop. Then second for the for size t, j equals 0, and so j less than size minus 1 plus j. Then for if this one, if a array j great, then array j plus 1, then called swap. Now you can see here swap, then ampersand, array j. So this is get the memory address of the array j, and ampersand array j plus 1. So if they are not in ascending order, so just call swap. So this is the same as the former bubble sort, just now swap is point. Okay, so this is the bubble sort. Then swap. Swap void the same, no return value. Swap int star element 1 point, int star element 2 point. Then we talk about this in int hold equals star element 1 point. The hold is temporary, the variable just save the value So now hold get the first value. Then star element 1 point equals star element 2 point. So this now first element get the second element. Then star element 2 point equals hold. So element 2 get the element 1. So this is like okay. So this is for bubble sort. So bubble sort. So now everything we now just use the hold to pass the array and also pass element. Let me run it. Okay. So this is the original node. The original node is node in the ascending order. Called the bubble sort function. So now the array now is in the ascending order. We talked about bubble sort before, so this is almost the same before. So this for loop the same. Okay, 2 for loop, then just the swap function change to use point. Okay, so this is the bubble sort. Okay, let me check. So again, so this one int star constant array. So this define the constant point. Okay, just remember it's constant point. So for one dimensional array, also then size it is constant. So size is constant, just it means array. You cannot change the array size. So the size of array remains fixed. So size is declared constant to ensure that it is not modified. Then the prototype for function swap is included in the body function of the bubble sort, because bubble sort is the only function that calls swap. We talked about it before. So placing the prototype in bubble sort restricts proper calls of swap to those made from bubble sort. So other functions that attempt to call swap do not have access to a proper function prototype. So function bubble sort receives the size of the array as a parameter, and this is constant. So the function must know the size of array to sort the array. So when array is passed to a function, the memory address of the first element of the array is received by function. So this is just the array name. Okay. Memory address of the first element of the array, so this is the array name. Then the size of array is explicitly passed to the function buffer sort the second parameter. So by definition the function to receive the array size as argument, we will enable the function to be used by any program that sorts one dimensional integer array of any. So this one we could have stored the array size in a global variable that accessible to the entire program. This would be more efficient because a copy of size is not made to the function. But however, other programs that require integer array sorting capability may not have the same global variable. So the function cannot be used in those programs. So global variables usually violate the principle of the least privilege and can lead to poor software engineering. Global variables should be used only to represent truly shared resources, such as the time. So here we just about it. Okay, so this is another operator, set of section 7.7. So actually, I showed this operator before. We get the int, long int, long int, float, double at this variables the size. Right? So this is the size of operator. Okay, so C provides the special unary operator set of to determine the size in bytes of an array or any other data type. So size the result of this operator set of in bytes. One byte has 8 bits, so you either remember. So one, so slow down. So 1 byte equals 8. So 1 bit, so it's just one binary number. So it has just 2 values, 0 or 1. Then 1 byte, so has 8 bit binary number. So we'll apply the name of the array as a next one. So array A, the size of operator returns the total number of the bytes in array type. Type T is long integer. Variables of the type of float of this computer are stored in 4 bytes of the memory. And the array is need to have the 20 elements. So 20 times 4 total 80. Okay, so this is another example. So now define the size t, size 20. Okay, so symbolic constant 20. Then this one, the size t, gate size float start point. So this is define a float point or a point to a float number. Then return the value is in size t, non-integer. Now it's non-integer. int domain void float array size. So this is defined array is type is float and size is 20. Then printf the number of the bytes in the array is %u. So now we get an error. Okay. No, not an error, a warning. So this is the 90. A warning. So we talked about before, so actually now it should be an LU. Okay, oh, this is another one. So this is the first one, then /n new line. The number of the bytes returned by the gate size is %u again /n. This is the LU again, 19. So 2% LUs first one get result from side of array. And also second one get the gate size array. So this is our function. They should get the same. Then this function, so size t, gate size plus then start point and just return size of 4. So we know this is array, the memory address of most element. So it's called side of again for the same. So this is actually here we should get the same. Okay, so let me run. Oh, different. Oh, made a mistake. This side of is the first one, the number of the bytes in the array is 80 bytes. Then the number of the bytes returned by the gate size is 8. This is 8. Size of, so this is the whole array size. This is the right. Then this is the point, is the array, the memory address. The memory address of this one. Then this is the point, should be the same. Then we turn the size of this one point. What's 8? Okay, so let me check. Okay, so now you can see slide also this. So the number of the bytes in the array is 80. the number of bytes returned by this size is 4. So in our 8, our okay, so the number of elements in an array also can be determined with the size of. So, for example, consider the following definition: double, real, or quite normal, 22. So variables of type double normally are stored in 8 bytes of the memory. Okay. But array real, so 22 times 8, so that's the 176 bytes. Then we can use this one to find the number of the elements in the array. Then the following expression can be used. The set of real divided by set of real 0. So this is the element, right? So we will get 8. Then one set of real, this is the total byte in whole array. So 176 divided by 8, so we should get 22. Okay, so then so for our the get size function here, so even though function get size receives an array of the 20 elements as the argument. So this is the array name, right? The function's parameter point is simply a point to the array's first element. Then when we use the set of with the point, it returns the size of the point, not the size of the items to each point. Just return the size of the point. So for this one, our point is the flat. Flat should by 4. Right? Is the okay. The size of point on our system is 4 bytes. So get size and 4. Okay, so this is why we get 8. So let me just do one more thing here. So this is the get size. So this is 4. Let me run again. 4 is 8. So in math, 4 is 8. We did this before. If you remember, we used this before. So float, float is this one. It's weird. Float is 5. It's 4 bytes. So you can see float is 4, double is 8. Okay. So the memory, so int is 4, non-int is 8. Yes, okay. So why is this the 8? So float, this is 8. Let me change a little bit. Should not be this. Yes, this is the 8. I don't know why this data 8. This is the floor, right? Floor point. A point to the floor. Okay, I can do one more thing. I can copy this one to online GDB. Let me do this and make it one. Okay, let me run this online. Yeah, it's also 8. So in the Mac, so float point is 8 bytes, not 4 bytes. Because online GDB is used in Linux, so it's also 8. Okay, so now we are now in Mac, in Linux, the point is 8 bytes. So it's 8 bytes in memory, not the 4. Okay, so this is another one. So that's the example. So calculate the number of the bytes used to store each of the standard data types of which was cycle. So this one depends in the operating system. Different operating systems may be get different results. So even different compiler on the same place maybe also get different. So I think this is why we get 8, but it's right. We get 4. Okay, so standard library. So now here we define the char. So this is one correct variable C. One character just is 1 byte in memory. Short as so this short integer. So should 2 bytes. int integer I 4 bytes. Long integer L, so 8 bytes. Long LL, so this may be 16 bytes. Float is just F, so we said before, 4 bytes, double, 8 bytes. Long double, LD, maybe 16. Then int array 20, so element is int, so 4 bytes. 4 times 20, so it should be 80 bytes. Then int star point equals array, so this is the point to array, right? Okay, so this is an integer point. So according to our result, it should be 8. So print f type of c equals % new t, so this is the one side of the chart. Okay, so 1, which is 1, then equals percent u, so this is 4 t. So first one, percent u, size of the t, so this percent u is for here. Size of c. So size of c, so this is for 1, correct. Then code this one, the size of char, so this is for the char, correct. Right. Then similarly, this one, \n, so we know this is just for u, right. The size of s, in short, equals percent u, so this is size of the s here. This one, size of s, so there are a lot. Yeah. By the lightning symbol here, so it means warning, because size of the return is size t. Size t is the long integer, so we should use LU for 80% UC. Okay, so this is size short, size of int, size of long, size of plus, size of double, size of the long, double, the size of array, at, size of the point. So now we need to change all the percent u to the L. So in this edit, VIM, so it's very simple. Start, so it's the current line, we just plus, so from the 0 up to the last line, then S for changing the percent U, right? So percent U is not highlighted. Now, then we need to change it to percent LU, then G for global. So because for each line has the 2, then if we want to make sure, so we can use GC for confirmation. But here, I don't need a confirmation. So you can see now all percent U now change to the percent LU. So now lightning simple here. We now not add. So now we can run it. Okay, so first one, size of the C equals 1 for 1 byte. Size of the chart 1 byte. Then size of short 2 bytes. Size of int 4 bytes. Long 8 bytes. Long also is 8 bytes. Then plus 4 bytes. Double 8 bytes. The long double 18 bytes. No, sorry, 16 bytes. Size of array 18 bytes. Size of point 8 bytes. That's the long is also the same as the long. Okay, so this is the size of. Okay, let me run it. So our check. If you remember, run it again. So we need to go back to the folder. So I will already compared, so run this again. So char bit, 8 bit, char minimum minus 128, maximum 127. This is the value. Then short byte 2, int byte 4, long byte 8. No. Outside int 4 byte flat 4 byte double 4 byte. This is the London maximum. Okay, go back to okay, so this is the set of for some variable. So operator set of can be applied to any variable name, type, or when applied to a variable name or a constant, the number of bytes used to store the special type of variable or constant is stored. The parameters, the parentheses are required when a type is applied a set of opposite. Points are valid operands in arrays. Oh, this is a new section now. Section 7.8. Point expressions and point arithmetic. So this means we can do some math operation to the point. So points are valid operands in arithmetic expressions, assignment and comparison. However, not all the operators normally used in this expression are valid in conjunction with point variables. So for points, usually we can do subtraction and addition. So a point may be incremented plus or decremented. We know actually a point is a whole number, an integer. Right? An integer may be added to a point, plus or plus. An integer may be subtracted from a point, minus. And 1 point may be subtracted from another. So this last operation is meaningful only when both points to the elements of the same array. Okay, assume that array int with 5 elements type is integer has been defined, and the first element is location of memory. So this is the memory address. Assume the point v point has been initialized to point to v0. So actually array name, the first element. So the value of the v point is 3000. So now that's the one example. So let's trace this situation for a machine with the 4 byte integer with the 4 byte number. Variable v point can be initialized to point any to array v with the either of the Okay, so this one, so V0, V1, V2, V3, V4 elements are integers. Each integer has used 4 bytes memory. So the point, V point to the first element, the V0. So then its value is 3000. So we also showed this before. Array just saves the elements in one by one. The first one is memory address 3000. The second element V1, so now it's 3004 plus 4. Third, for 3008. Fourth element 3012. Then fifth element 3016. So when we use the addition operator 3000 plus 2, so we get this result 3002. But when we use a point, the point, so actually we need to move point element by element, right? So this means the point should be jumped by 4. This equals 4. Then when we use this formula, V point plus equal 2. 2 here is not the byte. Okay, so this is actually 2 is the element number. So this is means the point will move to the right by 2 elements. So from V0, V1, then move to the V2. So the point now is going to V2. So it should be 3008. So this one is 3000 plus 2 times 4. Each element is 4 bytes. Now 2 times 4 is 8. Then the result is 3008. So move the point to the right by 2 elements. So this is the formula. Okay, so now the point now goes to the third element from V0 to the V2. Move to the right by 2. Okay, so then now this is example. So if an element is stored in 2 bytes of memory, then preceding the calculation will result in memory location of 3000 plus 2 times 2, so that's 3004. Okay, so just remember, so point, when we move point in array, point move is the element by element, not by byte. Then when performing point arithmetic on a one character just use 1 byte in memory. Then the result will consistent with regular arithmetic because each character is 1 byte. Okay, so now just suppose if this point has been increased incremented to 3016. So this is the last element we find. Then the statement v point minus equal 4. So it is move left by 4 points. So now point to this one, the move left by 4 points. 1, 2, 3, 4, back to the VG. So this is 3016. Then okay. So 3016 minus 4 times 4. So 4 elements, each element used 4 bytes. So now we get the result 3000. So if a point is being incremented or decremented by 1, the increment plus and decrement minus of it can be used. So because this way, plus v point or v point, if they are the same, just point to the last element. Then, so minus v point, minus, so this is move the point to the previous element. Point variables may be subtracted from one another. So this is the one. So v point contains the location 3000 was the element. v2 point contains the address 3008, third element. Then the statement 8 equals v2 point minus v point. So this one would assign x to the number of the element of the array elements from point v point to v2 point. So x will be the so will be two elements. So note 8 is the byte. So this one gives you the number of the array elements. So point arithmetic is undefined unless performed on an array. We cannot assume that two variables of the same type are stored contiguously in memory unless they are adjacent elements of the array. Only array store elements one by one. Okay, so a point can be assigned to another point if you both have the same type. The exception to this rule is the point to void class, which is a generic point that can represent any point type. All point types type can be assigned to a point to void, and a point to void can be assigned to a point of the any type. So in both cases, cluster operation is not required. A point to void cannot be deferred. So the compiler knows that a point to integer refers to a 4 bytes of memory allocated with a 4 byte integer, but a point to void simply contains a memory location for an unknown data type. The precise number of the bytes to which point refers is not known. The compiler must know the data type to determine the number of the bytes to be dereferenced for a particular point. So assign a point of one type to a point of another type if neither is of the type void, star is the syntax should be the same. D is told before, so D referencing a void star point is syntax. So comparing 2 points that do not refer to elements name. Point can be compared using the equality and the relational operators, but such comparison meaningless unless the point points to the element of the same. Point comparisons compare addresses stored in the point. A comparison of the 2 points points to the elements in the same array could show, for example, that one point points to a higher number of elements of the array than the other point shows the position in the array. A common use of point comparison is determining whether a point is null. Arrays and points are intimately related in C and often may be used interchangeably. Array name can be source of a constant, and before array name is just a point, so that's the memory address of the first element. Point can be used to do any operation involving array. Assume that integer array B5 and the integer point variable B point is defined. Now, because array name B defined is a point to the first element of the array, we can set B point equal to the address of the first element in array B with the statement the B point. We use this before, so actually array A. So this element is equal to taking the address of the array's first element of the string. So B point equals ampersand B0. B0 is the first element of the array. Array element B3 can alternatively be referenced with the point inspector. B point plus V. So this B point plus V move to the 3. Actually, this is the smallest element. Star, so it is the value element. The 3 in the expression is offset. When the point points to the array's first element, the offset indicates which element should be reckoned with, and the offset value is identical to the array index. This is because for in C language, array index star at 0 by 0. So this location is referred to as point offset. The parentheses are necessary because the precedence of star its value is higher than the precedence of parentheses. This is important. Without parentheses, then the above expression would add 3 to the value of the expression star B point. Star B point, so this will get the first element's value. So plus B, so it means 3 would be added to B0. Okay, so for array element, we can also use this one because the memory of ampersand is 3, or we can just use the B point plus. So star B plus V, so this also move to the B3. So in general, all indexed array expressions can be written with a point and offset. So in this case, point offset notation was used to the name of the array. So this preceding statement does not modify the array name in any way. It still points to the first element. Points can be indexed like the array. Okay, so if B point has the value B, the first element's memory address, the expression B point 1 so refers to the array element B1. So this is refers to the point index notation, point slash. Okay, so again, the array name is a constant point. It always points to the beginning of the array. Then B plus equals V is valid because B is okay, so the next example, so use the for method we discussed for referring to array name. Array indexing point offset with the array name of point, point indexing, and point offset with a point print for element of the integer array. Okay, so this one shall define array underscore size for non-body. So now int b, now this is empty, equals 10, 20, 30, 40, so 4 elements. So the size of the array b, so now we know it's just 4. Then int star b point equals b. B points to the first element. Now b point also points to first. Then put array b point printed with \n array index notation. For size t, I equals 0, I less than array underscore size plus I, then print f b percent l pieces u, so should be lu now, then equals percent d \n I b. So this is the exact number, then the \n, so this is new one. So this will get the one element in one. Then the next one, so put point / over that notation. So where the point is the array name. So we just use the array name. Similarly, for size t, offset equals 0, offset less than array size plus offset. Then print f. So now this is star b plus okay, size t again. Now size t is known integer. Then equals percent d. So offset. So this is first offset from 0 to 0, 1, 2, 3. Same as that now. Then star b plus offset. We used this before. So move the point element by element. It also shows the element in the point. Then the next one, put now point index notation. So for size t, I equals 0, I less than array size plus I, then point and b point percent lu, this is the exact number, percent d \n I b point. Now this is the point index. Then the last one, so put point / offset notation. Now we use the b point, not the array name. So for size t, offset equals 0, offset less than array size t plus array plus offset. Then print f, now start b point. B point to the first element. Then plus percent u, so lu again, then percent d equals. So offset the start b point plus offset. So similarly to this line, just here we use the array name. Then this one we use the point. Okay, so 4 methods show So first one use the array index. So B0 equals 10, B1 equals 20, B2 equals 30, B3 equals 40. Then use the point of that. So this is array name. Star B plus 0 equals 10. Star B plus 1 equals 20. Star B plus 2 equals 30. B star B plus 3 40. Then point is that. So B.0 10, B.1 20, B.2 30, B.3 40. Point slash offset rotation, so we just change this to B point. So star B point plus 0 equals 10, star B point plus 1, 20, B star point plus 2 equals 30, then star B point plus 3. So 4 methods to show the element. Right. Okay, so this one. So string copy with arrays. So now this is show this one interchange ability of the array at the point. So we just copy two strings. So copy one, copy two. So both functions copy a string into a correct array is just a string. After a comparison of the function prototypes for copy one and copy two, the functions appear identical. Okay, the commands accomplish the same task, but they implemented different, just different. Okay, so now size is 10. So void copy one, char star constant x1, the constant char star constant x2. So for this one, we render in the master if char star constant, so this constant point is constant. Then char constant char star constant x2, so both are constant. So char is constant and also the point is then copy two void copy two char star s1 then constant char star s2. So this is the point. No, the constant char. So this is the string int main void main function. The char string size 10, then char star string 2 equals hello. So this creates string 2, this point to string hello. Actually, it's the first element correct edge. So copy 1, string 1, string 2, then print f, string 1 equals %s, string 1. So now copy this string 2 to the 1. Char string size, string 3 size, then char string 4, so equals goodbye, good space by. So this defines 2 strings. Then copy 2, string 3, string 4. So string 4 will be copied to string 3. Print f string 3 equals %s, then string 3. Okay, so just copy 2 strings. Now copy 1. Void copy 1 char star constant s1 again. This is the tone is constant, but array could be changed. Array element could be changed. Constant char star constant s2. So for this one, both array and tone. Then for size t, I equals 1, then this one s1 I equals s1 s2 I is not equal to backslash 0. Backslash 0, so we know this is the end terminator of the array string of the string. Then plus 0. So this one, so actually in this the middle part do 2 things. So first one, do the assignment. So just assign the element in S2 to the element in S1. So that's the copy. Then check. Then the next one, check whether S1 is array, the element is not equal to backslash 0. It's not the end terminator. Then plus 1. So this will move the S2, right? S2 one by from the beginning to the end. Then copy the all element in S2 to just remember the size is 10. So this means S2, the size is not greater than 10. Right? So this is copy 1. Then copy 2, so use the different one, so void different method. Void copy 2 char star s1 constant char by 2, so array. Then for here, so know the next part at the beginning. So here star s1 is the first element value because star s2, so assign the s2 value to s1. Then check is not equal to backslash. Then plus s1 comma plus s2. So this is just use the point. Move the point one by one, and element by element to copy to the s1. Okay, so let me get the result of string equals hello, string 3. So let me do a little bit to this one. We said before to the second string cannot is turned to turn correct, right? So now just remember for the string array, the last element should be like 0. So this means that turn here the element, the total number, correct number in array only could be only have the 9 correct. So goodbye here. So now this has 8 and so we can add 2 more. For example, goodbye is so now this is the 8. This is so we have the 2 more correct. So this is the 4, 5 plus 3, so 8, then space, yeah, 2 more. So if this is the 2 more and correct, let me check whether I accept is true. Okay, string 3, so still wait. So you can see string 3 you get a goodbye. So this is because okay. So string 3 now overload, right? Overload. It's because for this one, the string this printf, this function didn't check the boundary of the array. We talk about this. So we can also use a for loop. Oh, this is good. Okay, this is one. This is also shifted. This is the same. Let me think. So printf is 1, 4. Let me check. So because now we have 2 more, let me check what happened. So one character that uses one character is the truth value. Okay, so let me check what happened. Data error. Oh. Okay, check this one. So we get the same without the so good, low, T, 5, 8, 7. And we increase this. Okay, so now you can see now we get this weird result now. So this is the next element shows in the saved in memory. This is the weird one. So this is over, yeah, out of. Okay, so we show the issue for this one. So in C language, print this one actually doesn't check the boundary. Okay, so function copy1 use array index agent to copy the string in S2 to the character. Then copy2, so use the point and points array method to copy the string S2 to the character array S1. So S3 to S4 to S3. So for this one, we talked about this before. The first argument to the both copy1 and copy2 must be an array large enough to hold the second argument. Otherwise, an error may occur when attempt is made to write into a memory location that is not tasked. The second parameter of each function is declared as the constant char. So in both functions, the second argument is copied into the first argument. Correct? Read from it one time, but correct are never modified. Okay, so just stop here. Let me talk about the homework. So homework. So this is the last homework. So 14, yeah, at least 21. Let me double check. Yeah, okay, so 1, 2, 3, 4, 5 is not the one. So just write this 5 example. It's not 5. That means the example. Okay, I will post this example. Then the last thing is about the final exam. Final exam will be on the coming month, so 1 week, the coming month. And the final exam only for 1 day, so only available on Monday, next month. It's because the policy, so you need to submit your result by the end of the month. Again, only have 1 day to finish this final exam. Not like the test, the both tests you did before you have submitted. So just 1 day to finish your final exam. And the final exam doesn't have the coding, doesn't have a coding program, only optional and random error. Okay, so this is